to try and do is to try and find an equation of them. Now, admittedly, it kind of looks a bit like a straight line. Bless you. Does anyone else know what kind of graph this could be? Because we have done functions, and I'm pretty sure, haven't we? We've looked at different. What does anyone know what kind of graph this might be? Okay, is it a quadratic graph? Okay, it looks a bit linear. Does anyone else suggest what it might be if it's shooting up like this? Or maybe an exponential graph. Nice, Bromballs. Alright, so what we're going to do now is in this input box down here that we all asked for it to have, yes? You'll find your input box.
Input box. Yep.
Remember I said on the right hand side to check the spreadsheet and the input box.
Well,
Somebody didn't hear that. Probably because I didn't send you the email. No, you can go to this menu button up top right and check the input box.
So that we don't have it checked?
Yeah, so you have it checked, so you've got it there.
So unclick it?
No. Harley didn't click it to show it. So, in this input bar, now this is what I keep forgetting, so you may want to write it down somewhere. Oh, well, I've got it recorded, so you can have a look at it later. Okay, you're going to type the word find.
It's like a word.
Oh, is it find? Wait, hold. I lied, it's not find, it's fit.
Like outfit.
Fit, for it.
F-I-T.
F-I-T, for it. And when you type the word fit, it comes here with a lot of options for you, okay? So what you're going to do, what the program's now going to do is to try and fit your list of points to be one of these things. Now, they're going to fit it to be a straight line, or they're going to fit it to try and be a log graph, or they're going to fit it to try and be a polynomial, or a power graph, or a sine graph, okay? Or an exponential graph, okay? So what we're going to do is once we've had fit, we're going to pick which one. Well, let's try line to start with. Okay, so we're going to try fit line. And then here you'll have at the bottom it says list of points. Yes? Now, you may or may not have noticed that after we entered all our points in, we've now got a list at the bottom. Okay, it automatically does that for you. So what we're going to type here is L, or maybe it has to be capital, L_1. That's not an underscore, Miss Harrison.
Mine is 2.
Oh, shut up. 2. Well, thank you.
Why is it underscore?
I don't know. It's just that's it. Okay, when you press enter, it will draw you a straight line. And it will actually tell you here at the bottom what the equation of that straight line is. Are you all listening? You all. Alright, so here's my straight line. Now, would you look at that data and go, oh, that's perfect. That follows all of the data, that's wonderful. No, probably not. So at this stage, we need to try and find a different equation. So we're going to do that again. We're going to say fit. And then you're going to choose a different thing. Maybe it was an exponential in the way that Bromballs say. So again, we're going to do L_, shush, it wasn't an _2. And again, it's going to give you the equation of the graph here. Now, the green one, would you say that was a bit better than the black straight line?
No. Yes. Yeah.
I'd say it was a lot better. Yeah? Yes, an exponential graph has an asymptote. Alright. Now, you may think, well, actually, I think it is actually just half of a quadratic. So you might want to say fit. Now, if you want to do a quadratic or a cubic or any other power, any other kind of graph like that, you do fit poly. Okay? Fit poly, because it's a polynomial. List of points again is L underscore 2. And then the degree of polynomial. What do I think my degree of polynomial will be if it was a quadratic graph? What would the degree be? Do you remember? It's the same as when we put in our calcs. When we say, oh, it says order there. It's just the power of x that we're looking at. So for a quadratic, what power of x are we looking at?
Squared.
2. So we write 2 here. And there we've got a red one that looks like a quadratic graph. Blimey, Riley, we're going to need another lesson on this anyway. Okay, so we'll just chat a little bit about this. I don't know how much time we're going to be able to get on this. We might have to finish this tomorrow. So in the other, in the email I sent you, I also sent you this picture. Okay? Now, another option could be that you choose a structure and you want to try and model the structure. Okay? Again, with it, whenever you're choosing what you're going to be looking at or what you're going to model, you need to have an endpoint in sight. Why are you going to do this? Okay, what is the actual point of doing it? Because in order to have a substantial project, you need to have a reason, a rationale, and you have to put that in your project. Not just because you wanted to find the equation that would best fit this arch. Think of something else that you might like to do about it, okay? Some other reason, make up stuff, but you need to have a goal, if you like, okay? Because in your conclusion, you're going to try and answer that goal or give more information about it, all right? So what we're going to do is we're going to copy this picture and we're going to paste it into the graph. Now, how do we do that? See, mine's opened in GIMP, which I hate. Oh, I'm going to pause it. All right, okay, so thank you, Jennifer, for your assistance. So I now have my image on my axis. So however you do that, I don't mind. Now, this is important to me, and Mr. Potts and I discussed this. When you are putting your picture on here, you need to think about your scale, okay? Now, your scale being 0 to 6, or seeing that my graph here goes through the point 0 and 6, is not actually very meaningful if you're actually doing this for some kind of purpose. What you need to probably look at is the dimensions of this arch. How wide is it? How tall is it? Well, no, I did find that information. But anyway, so you would then need to alter your scale to make sure you're fitting your picture appropriately. Now, I believe you can make this bigger and smaller, can you? Maybe not.
Yeah, if you click on the blue dots at the bottom.
Does it drag it? Oh, look at that.
That's what I was doing.
Okay. So you can make it nice and big so you can actually see it. Okay, you can then scroll in, but as I said, in my mind, you have to have your axes at sensible scales, okay, using sensible scales for real life measurements, okay? So I wouldn't have this as 16, I'd find the height of it in real life and change my my axes accordingly. Now, what's the point? Yes.
Add something to that. So for this, having a realistic scale, I know, and Saracen was just talking about have a reason. So for instance, you might want to ask a question to start your whole IA off, like, what's the biggest thing that I could fit under the curve? You know, could I fly a plane underneath? Could I fit a blue whale? I don't know, something ridiculous. So you might then want to find the function and then integrate it, for those that are going to go that far, and you've got the area under the curve and you can compare it, but you can only do that if the function that you're going to integrate is realistic to the actual curve. So exactly like Miss Harrison said, you've got to have realistic numbers.
And it may be that you want to find that you know you've got something so high, and how far out does it have to come? So you'd be solving which two places is something of a certain height, for example. That's another option that you might have. But for any of this to happen, this function needs to be realistic, using realistic and real life measurements. Otherwise, it's all going to go pear-shaped. Okay, so we've got that far today. We will pick this up tomorrow and I'll show you how you actually input points on here. Okay?